Welcome again to the series about cloud computing. This is today a meetup about managing data. It is motivated by a couple of real-world use cases. So with Linda, we're working on the cloud and we are collecting data, and there was a point where the droplet that we were using and sharing did not have enough space to continue our work. So we learned how to increase the disk space to store more data, and that turned into this meetup. And also I'm going to be showing how we can use, once we learn how to increase data, I'm going to show how we can share data across different members of a team. We mentioned the pins package before, and this time I'm going to not explain a lot about the package, but I'm going to explain how you can use it in the context of sharing data in a cloud service. So pretty much what we do now at Resize with Dropbox, how you can do it in a better way. Also, I plan to talk about how to move data around, but that's probably not going to happen today because we won't have time. So likely next week. So as usual, the meetup has a dedicated folder. So I'm going to navigate to number 3, data, and that's the notes. So the user story that motivates this first use case, which is the idea of being able to increase the disk space to store more data. The user story would go something like this: as an analyst, I would like to increase my disk space as my data grows, which is exactly what we had to do with Linda. So there's a couple of approaches to that. Let me sign into the cloud service that I'm using, which is DigitalOcean. If you don't have an account and want to try it, it's free to sign in, and you get $100 credit that you can use over 2 months. It's going to be more than enough to try the things that we're showing in this series. This is kind of my dashboard. I'm going to log in. I'm already logged in. I'm going to go to this demo project that I have here on the left, and there is a droplet, which is no more and no less than a computer on the cloud sitting there. I created it from here a couple of meetups ago. If you need to refresh that, feel free to go back to YouTube and see those videos. The first thing you could do to resize the data is click on the Resize tab here. That is something that we have used before, but we used it to resize, for example, the memory of the droplet, and now I would like to use it to resize the disk space. So that would be something similar to basically buying a computer that comes with a bigger hard drive. So you won't see options in the first page here that come with more than 25 gigabytes of disk space. For that, you have to choose either here in Storage Optimized tab. So that seems to be something new, and that if you click there, let's see, actually that doesn't give me what I want. Well, forget about that. You click here on disk, CPU, and RAM, but also note the message here that this is a permanent change. So once you increase the size of the droplet, you cannot go back because that could cause some data to be lost. So you can expand, you cannot shrink. So clicking on that gives you some options with a lot more space here. So with that option clicked here, then you can also see for like more basic things here, I think. Let's see. Yes, so I could do within the resizing that touches disk space. You still have a bunch of options here on the tabs. So now you can see how some options have more disk space, 160, 320, and so on and so forth. And if you really want a lot of space, you could do this. But this is very expensive, as you can see. Like 300 gigabytes costs $125 a month. There is another way, which could be equivalent not to buying a bigger computer, but instead to basically buying a hard drive an external hard drive and attach it to your computer, say through your USB port, right? So that's the option that could be applied here. If you go to volumes, what you can do is you add a volume, which is simply attach an external drive to your droplet. Your droplet stays as big as it was, but now you are connected to a storage device that can have a lot more space. So that is what we're gonna do. You just click add volume, and then you can choose among a bunch of options. The 100 gigabytes, for example, is good for me, and it's pretty cheap. So I'm gonna also name it in a way that is a bit more friendly. Just volume is enough. I'm gonna give a name to that. You can see it's going to be attached to the droplet that we were seeing before. The droplet comes already with 25 gigabytes, but I'm going to add these 100 gigabytes on top. And the other options are fine. Just allow this automatic format and mount, whatever that means. Click here on create volume, and you're good to go. The next thing I'm going to do, so you see now that under the name of the droplet, we see the volume already included. Also, I would like to note that you can change your mind later and make it even bigger. So you can go to increase size and choose bigger space. I'm not gonna do that. I don't need it for this demo, but something you could do. And then of course you can delete it, or you can add more volumes, right? So for the one droplet, you can have multiple drives connected to it, right? Similar to your normal computer, you can connect multiple external drives. So basically, there is no limit to how much data you could associate to your droplet. So now let's have a quick look at how you actually interact with that volume. I'm going to do a little peek into that volume, at least to find it in our system. And then it's going to be the end of this use case, and then we move on to actually using that volume for example, sharing data across team members, something that is a bit more pro than doing it with Dropbox. So I'm going to copy this address here that I mentioned many times before. It's called IPv4. The name is not important. The idea is that this address allows us to pop up, for example, a normal terminal in my computer and use the program SSH and say, hey, I'm going to be the root user at this specific address, at this specific droplet. So by running that, you connect directly to that droplet, and you can use the command df, which allows you to inspect information about the file system of any computer, including your local computer. I'm going to use the flag -h, which I think it means human readable, or something like that, so that this is going to inform the information with units of size that are more readable than I would get otherwise. So from all this information, I want to highlight two lines. So this one here shows that the droplet comes with those 25 gigabytes already in it. Like if you're curious, it's 66% usage. So I have not too much to go before it's totally full. And then the second line I want to show you is this one here. So another device attached this time to the droplet that gives me 100 gigabytes, right? So this is where I can store most of my data, similar to Dropbox. Also note where it is. It's mounted on /mount /volume. So volume is the name that I gave to the volume. If I said my name would appear here. But mount is a directory, this one here, that is by default chosen by DigitalOcean. You can change it, but why would you? It's a very sensible place to mount a volume. So that's it. Then you could do the normal tools like ls for /mount to see what there is in there, and fair enough, there is a volume right in there. So that is the end of the first use case, the idea of how to increase the disk space so that you can store more data. So now we're going to move to how to use that volume to share data across team members. Before we do that, maybe it's a good time to make a little pause. See if there is any comment here, any question. Okay, good. So far, it has been more like learning about how to do something on DigitalOcean, which is not all that interesting. Probably the biggest takeaway is that in most cloud services, I would expect you to be able to find a way to make the space for storing data bigger, so that you know, as your demands increase, you can also adjust your infrastructure on the cloud. And now I think it's something that I find more useful, or at least interesting, from the perspective of an analyst. The idea that, okay, as an analyst working in a team, I would like to have a way to share data that is better than Dropbox. Dropbox has caused some problems before because of the paths that we need to kind of type on our computers. Also because to use it fluidly, you need to have kind of Dropbox desktop installed on your computer, so it's sync with the cloud. Also, it's used to store probably too much data, so if you sync everything, then your local computer kind of blows up in space. There's a bunch of issues, and there are tools that do that job a lot better. So if you use R or if you use Python, then the Pinch package can help you. Basically, it's similar to Dropbox. You just say where data will be kind of stored, and you can put it there. But one bit that I'm going to be showing now is also kind of the behind the hoods of creating a folder similar to Dropbox, so that it is possible to share it with team members. I think if you were in the previous series about the terminal, you will you might remember that when you create a directory somewhere in a multi-user system, that directory is not accessible to everyone. You need specific permissions. So the first thing I'm going to show is how you can pretty much create a folder that is shared and everyone has permissions to read, write, and execute anything in it. So it's fairly simple. So we're going to be, let me move this to the right, and so I have my terminal here to the left. So the first thing I want to do is, we already know that our volume is here in /m&t, so that's our volume. So what we want to do is create a directory inside it that we're going to dedicate to shared data. So inside volume, we want to create a folder called shared, so it makes sense, and we are going to create it with the command make dir. So now if I do an ls on mount, I'm going to do it with ll, which will give not only it will show the contents of something, but also the permissions. So here you can see that the folder shared can be written by and executed and read by the owner, in this case root. But what this means, and you might need to refresh what this means in the previous series about the terminal. What this means is that no one other than root can write things to here. For example, they can read things, but it's pretty limited, the permissions of this folder. So we need to change that to make it similar to Dropbox, in that anyone can read things, write things, and execute things in it. So we're going to do that with the command change mod. This is it. So this is very technical. It's not something that you could do if you're working, for example, for 2 degrees. It's something that I would do, but I create that folder and then you use that folder. You can just simply read, write, and execute things in it. So the command that I just run, what it does is change those permissions so that everyone, all, that's the A stands for all, gets read, write, and execute permissions. So let's confirm that with the LL that we did before. And now, the name shared prints in green, and we see that every group of 3 letters here have R, W, and X. That means that everyone can read, write, and execute things in it. So that's what we want. So that's all that you would, someone like me would do behind the hoods to make that folder inside the volume accessible to everyone. Why I do that only in a folder and not to all the volume? Well, because the volume is a big thing. We might want to use it to store a lot of other things, including data that is private for each specific user, and one user can write something there that another user does not see or can change or remove. So I create this specific folder for shared data. All right, so the next thing is also something that is more kind of developer oriented, is the idea that, okay, so now we have data, we have a volume where we can store data. So now let's give different team members different little computers. So like, for example, Linda and me, we could be now playing the role of analysts, and we both have each one container each, or one little computer each, where we can do whatever we want. We have a password, we do our thing, but both of us can write to that shared folder, so that, for example, Linda can write a file that then I can read. So that would be the experience that you have with something like Dropbox, for example, right? So what I'm gonna run now is, again, pretty technical. It would make sense if you see the series about working with Docker. Basically, what I'm doing is I'm running a little computer on that cloud for Linda. I'm gonna name that computer Linda, and I'm allowing her to connect to that computer on a specific address with the number 8787. She has a password for it, and she can see from inside that little computer the shared folder I have just created. So she has full power to do whatever she wants in that little container, and she's running basically a computer that already comes with R and with RStudio installed. So I'm going to do the same for this other user. The user is going to be Mauro, me in this case, so for a second analyst. So these two analysts have...
Mauro?
Yes?
By the way, my one passed.
Thank you very much. Awesome, I think we are on time. Great. I'm going to push, I think another 5 minutes should be enough to kind of demonstrate what I want to show. So now I have created those computers, so I'm going to show you that, Docker PS. Again, this, if you're scared about what you're seeing here, don't worry, this is something that you could not likely need to do, but I need this for the demo. I need to show, okay, Linda gets a computer, Mauro gets a computer, how they can share data. So this command, Docker PS, shows running little computers inside that droplet that we have on the cloud. So we each have one with a password. So now we are going to connect to that. I'm going to connect Mauro, I'm going to connect Linda, both to their own containers, and they're going to basically share some data. So what I do now, I need to go to DigitalOcean and get that address again. That is always super useful. That address allows me, in this case, I'm playing the role of Linda. So Linda connects to the port 8787 on that address with the username RStudio, and the password, her password is 123. So here is she, and she can go here to the left. And now I'm going to open a private window so I can get another user signed in. And here I'm going to connect again to the same address, but now to the port 8788. Mauro got that port. I'm going to run that and connect him with, again, RStudio as a user, and his password is 321. So signing in him here. All right, so both of them are going to be working with pins, so they need to install the pins package. Yeah, we do that for Linda, and we do that here for Mauro too. And now let me just copy paste from my notes, if I find them. Where are your notes? Here. So what we are gonna do now, so now the experience is that of an analyst, right? So we have Linda in here to my left, right? And what she's gonna do is, she already logged into her container. She's gonna do library pins to start using it. She already installed it, so she has access to that package. And now she's gonna create what's called a board. A board is simply a pointer to a folder. So she's gonna use a function that comes from pins. It's called board folder. And she's gonna give the address where she's gonna store data so that everyone else can see it and do whatever they want with it. So it's gonna be at mount volume inside that shared, and she's gonna write a specific in a specific folder called pins inside that shared volume. All right, so that's the board. The board itself is an object that is not very interesting. It just does things, but if you print it, you don't get a data frame or anything like that. But now she will actually work with a data frame. She's going to be using, say that she wants to work with the dataset empty cars. This is what it looks like, right? So she wants to make that dataset available to Mauro. So what she's going to do is she's going to use that board to store it there, and she's going to write that pins. The object that she's going to write is the object empty cars. So that's why it does not have quotes, because it's the symbol for the object. And then she's going to name it empty cars. Or it could be something different. It could be my data, my data. Okay, so the pin has been written. You could confirm that also by, if you were the cloud administrator and you did an ls on mount volumes, then you will see that there is the share directory, and inside it there is a pins directory, and now my data appears there. But if you are Mauro, then you could be in this other place. You would also need to attach the pins package, and then you also need to say, well, which is the board that we're going to be connecting to. So we're going to do the function board folder, and he's also going to point to mount. Why did that? MNT volume shared pins. So he's going to connect to the same board. Sorry, there you go, pins. Right, and now instead of writing data, he's going to use it to read it. So board. Actually, I'm going to use the pipe that comes from base. So the board, and he's going to use pin read with the name my data. So that was the name of the data set, and there he is. So as you can see, we have used the pins package to read and write data to a shared directory, and that shared directory is now inside a volume that is pretty big, has 100 gigabytes of space, that has internally a shared folder for different team members to work with. All right, and that gets us to the end of the material. So let's go back to your faces and see what questions or comments we have. Okay, nothing here. Maybe I'm gonna take a moment to wrap it up. It could be a lot. I think it is generally confusing when I play the role of the developer and the analyst, and it might be overwhelming to see actually what a developer has to do. And I feel that you might have the impression, oh shoot, I don't want to do all of that. That's so much work. But so what I'm gonna do now is kind of distill what we've learned today, but only from the perspective of the analyst. So for an analyst, basically they get a link to a little computer on the cloud, so they put that link on their web browser, and they can log in to something like RStudio. They just use a username, for example RStudio, and a password, for example 123, and there they go. They are dropped into a system that has everything they need. If they need something else, they might be able to install it themselves, or they can also ask the cloud administrator, so that, for example, that RStudio environment has specific packages, for example, right? So that's all they need to do, basically point the browser to a specific address, log in with a username and password, and they're dropped into this environment. And now when they need more data, when they have a lot of data and need more space, they can ask the system administrator, and the system administrator would add, for example, a volume, so that suddenly their little computers have a ton of space. They may also want to share data with other team members, so they need to know exactly which is the folder that is dedicated for that. It makes a lot of sense to put in a specific place, like for example /mount/share, /mount/volume/share. And then if you want a very good way to share data in R or in Python, would be with a pins package, which has a dedicated series that you can find also on YouTube if you want to learn more about that. Okay, so that wraps it up from the perspective of the analyst, and it's the end of the meetup. So before I go, I'm going to ask one more time if there is any question or comment. And if not, we'll leave it at that. Thank you very much, everyone, and see you next time.
Thank you. Bye.
Ciao, ciao.
Thanks. Bye.